Okay, we're having some problems with tracking these equations. Currently, between Monday and Wednesday, or between Tuesday and Thursday, maybe you didn't have time to get the assignment done, but you got to assume that you did, okay? Because there's a whole lot of stuff. And what we're doing in this course is we're basically making up 2 complete years of high school algebra. Okay, so you got to spend the time on it, make sure you stay on it. And I know things can come up. I've had stuff come up this week, which prevent me from doing things that really be better if I could do it. Okay, so it can happen, but try to arrange things and set aside plenty of time. When you go through the open math, take notes. And now, one thing I told my class, I think it was my MD 61 class, in preparing for an exam or preparing to know the material, you want to have a notebook. And what I would recommend, since we're going to have a test here, maybe at the end of next week, probably beginning the following, you start preparing for that test by reviewing, taking notes. Also, I think I emailed, did you get it? The link
Yes, sir.
to the
Yeah,
open stacks and stuff?
Everything. is
Okay,
text.
so you have textbook there, okay? And one thing I'd like to do, and if you email me, you'll prompt me to do it, because between this class and the next, I don't always look at my notes. Okay, because there's always more to do than can be done. And it could slip by my attention, but I can give you section numbers, chapter numbers, and so forth, so you can read about it. And basically, you just need to read the whole text. It's like 1,000 pages. So I can't expect you to do that. Although it'd be best for you if you did. There are 24 hours in a day, and you've got other things going on, jobs. Some of you even have other classes. Okay, so I know we got to be realistic, but of course, you really got to put some time in it, because we're moving into the intermediate hour. Okay, so you want to stay up on the assignments. You want to do everything you can to get it done. Okay. One thing I recommend is, I think the way I said it yesterday was, if you're looking at the text and you see something that's highlighted, it's obviously supposed to be important. Okay. You will have almost certainly seen it in class. You will have almost certainly seen it in OpenStax if you've done the assignments. And if it's really important, that's a sign that you really want to make a note of. So you don't always have to look it up in the textbook. And then eventually you want to make it second nature by doing a lot of problems. If you're not getting enough problems, it's fast, I can give you plenty. Okay. But by reviewing the OpenStax or the open math, you can make quite a bit of progress, because if you do a section for review, it's going to give you different numbers. Problems are going to vary slightly. So you need to do that for review. Go with the assumption that I'm going to let you bring some cheat notes to the test. Okay, but the cheat notes are limited to 100 symbols, letters, okay, symbols, slashes, okay. So, like, you can do all kinds of shortcuts. We haven't yet done the quadratic formula. That's a really good example. But if you want to remember the equation for the slope, okay, don't write slope equals x1 minus x, or y1 minus y2 over x1 minus x2, right? Just delta x over delta y. Changing delta y over delta x. I don't know why I'm reversing that. Okay. You write delta y over delta x. You don't even put the slash, write a delta y here, and a delta X here, because you'll know what that means when you see it. So be thinking how you could, number one, identify the really important things you're going to need to solve the equations, or to solve the problems. And then keep looking at that as you work through it. You know, look at it every once in a while, remind yourself of what it means. And start with, I don't care if you got 100 pages of notes, but condense it down to the real essence. The things that you're really going to need, things that you're most likely to forget. And somehow show that thing. So instead of writing slope, which is 5 characters right there, or M, which reduces it down to 1, okay? Equal sign, that's another character, you're wasting characters. If you know what slope is, just seeing a delta Y and a delta X under it without a slash, because that's an extra character, okay? Or you can find a way to abbreviate it even more. But don't write Y over X. That's not going to give it the slope. Okay, now, the thing that you want to know here is that the x-intercept occurs when Y equals 0. Why is that? Here's your set of coordinates. Here's your x-axis. Here's your y-axis. Okay. An x-intercept is where the graph crosses the x-axis. The x-axis has the same y-coordinate all the way across. What's the y-coordinate of this? Show me with your hands. Show me with your fingers. No, that might be the x-coordinate. That's not the y-coordinate. Yeah. Okay, so you know, right? What's the x-coordinate? What's the x-coordinate of this point? What's the y-coordinate of this point? Yeah, y-coordinate of this point. What's the y-coordinate of this point? Yeah, some numbers. What's the x-coordinate of this point? Okay, x-coordinate of any point in the y-axis is 0. You want to know where the graph crosses the y-axis? You've got the formula for the function. You're going to substitute x equals 0. X-intercept occurs from y equals 0, and there might be several x-intercepts. For a straight line, there's only one. Okay, maybe none, because the line could be just plain old flat horizontal up here someplace that never touches the x-axis. But it's got anything but a 0 slope. It's got to hit the x-axis either somewhere over there or somewhere over there, or maybe even if you're unlucky at the origin. Okay, and the y-intercept x equals 0. So when you have the question, when you're going to graph a linear function, the first thing you probably want to do is say, okay, what's the x-intercept? What's the y-intercept? That's it. If you know where the x-intercept is down here, where y equals 0, then you know what to do. You know to plug in y. And if you do it on a number of problems, then it's going to stick in. And then when you get the test and have to graph a linear function, say, oh, that's easy. And it is, if you remember what to do. Okay. And you know, most of you are doing it. You might not have the right x or y coordinate, but your first impulse is to draw a graph and do all this stuff. You know, your first impulse is to remind yourself, okay, x-intercept y has to be 0, y-intercept x has to be 0. That's where you start. Now, if you really want to draw a set of coordinate axes to focus on, that helps you go ahead. It takes like 1.8 seconds to draw a vertical line, the horizontal line, across it. Okay. And it's not a distraction because you're going to need it. But first thing to do is not sit there and draw this thing and then mark off 78 points on each axis when you don't even know how many points you're going to need. Okay. The very next thing you do is you write down the equation of the function. And you remind yourself, okay, x-intercept y equals 0, and then you proceed. You write that out. And you write this out, and then you proceed. Same way you've seen me do it. You don't fish around. You know what to do, okay? You focus on it. So, focus on that, and let's see if you graph these equations. Okay, I encourage you to write it out the way I'm doing. Imitate what I'm doing until it sinks in. Or if you find a way you like it better, an open math that really causes you to understand it and gives you something to sink in, then do it that way. The way I'm recommending is you write it out logically. The x-intercept occurs when y equals 0. It tells you right now what you're going to do. You're going to let y equal 0, and you're going to get the equation. Zero equals 9x minus 4. Now I'm going to put 3 dots down, resolve the equation, which you know how to do. And you get x equals 4/9. So the x-intercept is 4/9, 0. Because your assumption here, where you got x equals 4/9, so you assume that y was 0. That gives you this point. Now, what a lot of people do is they find the x and y intercept and think that those are 2 coordinates on the graph, and they are. Okay. So that's how it's written out. Can you write it out in exactly the same form for the y-intercept? Write out all the steps and all the words. If you're not writing out the words, you're just imitating without thinking, okay? Now, you might just be imitating the words, but if you imitate the words, it's better than just imitating the numbers without even thinking about what the reason behind this is. If you understand the reason behind it, then you're going to remember how to do it. If you don't, you're not likely to remember. Okay, well, the same process for the other equation. Let's say this is one equation, one of your equations, and this is the other. If you just do what it says, x-intercept y equals 0, you plug in 0, and you get your x-intercept. And the x-coordinate is what you got, and the y-coordinate is 0. Same process gives you y-intercept, which is going to be 0, 2. So now we've got a graph. Everybody's graph, no matter what your numbers are, is going to include the point 0, -4. My graph includes the point 4/9, 0. Now I'm going to need a point for the y, for the x and y intercepts here, so I'm going to have a let's put the corresponding colors. Okay, the y-intercept of this one that I circled in purple is going to be this. I'm not going to do the x-intercept yet because the x-intercept is really small. This is going to be really close to the origin. It's going to be a really steep line, and everybody's going to have gotten a really steep line because of the way I set the thing up. We're going to see what the x scale needs to be by putting 5 here. So your x-intercept of the one I circled in blue is 0, 2. Now, I also know the y-intercept of this one, which is 2. Now, if this distance is 4, so that, here's -2, -1, 0. Well, +4 up here has to be here, so 2 is going to be here. So the point I said here makes no sense. This is 5, 0, not 0, 2. I'm going haywire in my brain where the last thing I see is what I write. So, I know what to do. Okay. X-intercept here is your 5, 0. Okay. The y-intercept is 0, 2. So I labeled my 50.02, but it's 50. And it's like put it out there. Okay, so there's 5. Now let's just kind of. It's not a very good subdivision, but I'm going to use it anyway. So here's 1. Where's 4/9? Because we need the x-intercept 4/9, 0. That's going to be a little less than a half. That's going to be like here. So now my line might look like this, where the y equals 9x minus 4. And here is my y equals my 4x plus 10y equals 21. Where do they intersect? They intersect here. And what do the coordinates of that point look like? Well, I'll estimate it. I'm going to draw a horizontal line through the point. And I'm going to draw a vertical line through the point. And it looks like here's 2, so here's 1. Looks a little closer to 2. Well, I'm going to say it's about 1.5. And here, x is approximately 0.8. So the crossing point is 0.8, 1.5. I'll put a question mark there because it's unlikely to be exact. Okay. So that's how we solve this problem. We estimate the coordinates at this point after we do the graph, and it's really easy to find the intercepts. If you just know what you need here. If you just remember the x-intercept occurs when y equals 0, the y-intercept occurs when x equals 0. And then remember, when you assume that y equals 0 to find the x-intercept, the coordinates of your point are going to be whatever the x is here, and 0, because this depends on y being 0. Well, it wasn't 0, you wouldn't get this x. So this has to be a point on the graph, and you can plug it back into the equation. Plug x equals 4/9 back into the equation. 4/9 of 9x is 4x, is 4, and 4 minus 4 is 0. It works. Okay. You don't. Well, okay, then you repeat the process for the y-intercept. Same thing. I'm not writing it out, but you can write it out. Write it out in the same form. Okay. Y-intercept, x equals 0. Write that down. So you reinforce the idea. And then just follow the steps. Everything is obvious after you write out y-intercept when x equals 0. Same thing over here. Write out x-intercept and y equals 0. The same process, we're going to write out y-intercept when x equals 0, and then just follow the steps. And you know how to follow the steps. That's not going to give you any trouble. Although you might mess up once in a while, like I never do. Okay. Then you know how to plot the points in the graph, and you know how to draw the lines. That's not an issue. Focus on this. That's all you need to know. And that and a little practice. And it's just like falling off a log. Okay, well, then what do you do? Well, then we want to see what the real answer is, so we use substitution. So find the exact crossing point. Okay, we've got the two equations, y equal, what did I say, 9x minus 4. And I have 4x plus 10y equals 20. Okay, y equals 9x minus 4. Then we can substitute 9x minus 4 for y. Because 9x minus 4 means the same thing y does. So when I see y here, I can replace it with 9x minus 4. So we get 4x okay. In other words, I substituted the 9x minus 4 for the y. Since y equals 9x minus 4, that has to be the case. If both of these equations are going to be true, this is true and this is true, well, since this is true, this has to be true. Now, you can solve that equation. And I normally give you time to solve it, but you know, we got a little hung up on the graphing. So I'm going to solve it for you. 4x plus 10 times 9x minus 10 times 4 equals 20. I just applied the distributive law. And then I multiply things up. 4x equals plus 90x minus 40 equals 20, which gives me 94x minus 40 equals 20. Now, that's 94x minus 40 plus 40 equals 20 plus 40. So 94x equals 60. Okay. And you know, if I give you this equation, you're going to do this. Okay. And I think you're going to do it pretty reliably. I think you know how to solve these equations. Okay, so this tells us then, I'm going to just do a couple of dots, because you got to divide by the 94 and then think, okay, 94x over 94 is 94 over 1 times x over 1. Sorry, yeah. It's 94 over 94 times x over 1. Switch that stuff. So x equals 60 over 94, which is approximately equal to closer to 0.6 and 0.5, and an extra decimal place here wouldn't make much difference on the graph. So I'm going to say it's about 0.6. Let's first say what it equals. $30 over 47 is approximately 0.6. We're not going to use that 0.6. We're going to use 30 over 47 in our solution, because we still have to find the y coordinate. This is telling me that, okay, you know, when I graph this and everything, it wasn't completely accurate. My 4/9 was over a little too far. And I got 0.8 instead of 0.6. Still close. So that having graphed it, I can see that my solution is reasonable. It makes a certain amount of sense. Well, what do I do with that? I'm going to take the x equals 30 over 47, and I plug it in for x in the other equation. Okay, I used this equation, and then I plugged into this equation. I got the solution. I want to use this equation, although I could use this. Okay, and I'm going to get 4 times 30 over 47 plus my equals 20. What's 4 times 30 over 47? I don't really care at this point because I'm going to multiply both sides by 47. I am going to cheat just a little bit. Multiply the 4 by 30, because 4 over 1 times this. So, okay. I don't want to have an extra step. Okay. So I get this. The dots are going to lead me to 120 plus 470y equals 940. Now you probably already have that much in your head, right? Okay, well, follow the steps. Okay, and then a few more dots, and we get 470y equals 820. So the y equals 820 over 470. Okay. And that comes out pretty close to 1.8. See. No, that's not 1.7. So my 0.8, 1.5. Corresponds to an approximate solution of 0.6, 1.7. Now you can reduce this 82 over 820 over 470. You divide both numerator and denominator by 10, you get 82 over 47. Put in those terms. And 47 is a prime number, so that's not going to simplify any further. Open math will probably ask you for decimal approximations. And that's appropriate in this case. But we want to be able to work with a fraction, so I worked it out exactly up to the point where I approximated these numbers. Assuming I did that right, and I'm pretty sure I did it more or less right because it agrees pretty well with my estimate in the graph. That's the whole process you needed to do for assignment today. So if you didn't do that, get it done. Now we need to move on because we're moving right into intermediate algebra at this point. And we're going to start by looking at the rules for exponents. Okay, the rules for exponents are really just common sense if you know how to set them up. Like, for example, what's 2 to the third times 2 to the fourth? Well, that equals 2 some power. What power would that be? Can you tell me what power that is? We'll pause for a second. Okay, well, I got an answer to this, and the answer was 12. Okay, of course, you're multiplying here, and you want to multiply the 3 and the 4, right? But that's not going to work. And we're going to see very easily why that doesn't work. So you want to get that out of your system. And then somebody said, oh, okay, 7. Okay. And that's good, since there are only 2 people here you today. Okay, well, why is this? It's 2 to the 7th. Not 2 to the 12th. Why? Because 2 cubed means what? It means 2 times 2 times 2. I assume everybody knows that. Okay. If you don't, now you do. Okay. You did. Now you do. 2 to the 4th then means this, right? So means this, right? How many twos you got there? 7. Okay. And this is the same as everything's multiplied. You multiply them in any order, in any grouping. And that's because of the associative law and commutative law. You don't really need the commutative law here. We're not going to confuse you with that at this time. That's just common sense. There's a law for that. Okay. Associative law basically says it doesn't matter how you group things. If you got a series of multiplications, you group any way. It's actually stated a little more basically than that, but that's, yeah. Okay, so there's a law for this. There are only about a dozen laws in all mathematics. Well, at least this, okay, everything else comes from those laws. So all you got to do, you got a dozen rules. It's a game, you just learn to play the game by the rules. You don't learn 1,000 tricks. You learn a dozen rules. And then you can try any tricks you want if you can check it against the rule. You learn what you get away with and what not. Okay, you learn what you can get away with and what you can't. So this is unit 7. Okay, the rule. You multiply a to the b by a to the c, you get a to the b plus c, not a to the b times c. Okay. Why? Because that means you got b of these, however many that is, and you got c of these, same thing. So if you got b of them and you got c of them, how many do you have all together? Okay, well, even though they put a calculator in your hand at a young age, you still understand that much arithmetic. Okay, good. Okay, so here's another one. What's 2 to the 3rd to the 4th power? We'll stop and talk about it. Okay, so the first guess I heard was 12. There's also guess 64. The 12 is the one we heard, and that was right. And after knowing the 12 was right, somebody admitted this. Oh, I got 64. Okay, that's all right. Okay, why? Well, somebody said because it's out of a parentheses. Okay. Well, yeah, it is, and you want to recognize that so you can really get to the heart of why it is. So that's an important thing to see. Well, 2 to the 3rd to the 4th means when you raise something to the 4th, that means you're going to multiply 4 of them. Right? Okay. Now, I'm going to give you a chance to tell me where that's going to go. Okay. Now somebody wrote 8 times 8 times 8 times 8. Yeah, but it's not going to get us back to rules in terms of A, B, and C. Okay. So if we write this out, this is 2 times 2 times 2. That's this one. Usually I didn't leave myself room. So let it run over. Okay. Then again, since I can group a string of multiplications any way I want to, and do them in any order I want to, but the order doesn't matter because they're all 2s. I can write this as I have a pen back here, but there's 1, 2, 3, 4. Yeah, there are 12 of them. Well, if you understand that every 2 to the third is a string of 3 2s, and there are 4 of those, then it's no surprise that you end up with 12. Okay? Okay, so the rule. A to the B raised to the C is A to the B times C. Okay, first of all, x to the 7th, y squared to the 3rd means you're going to have 3x to the 7th, y squareds, right? So we're going to come down here, just at the side note, and just kind of write this out. Okay. X to the 7th, y squared to the 3rd just means 3 of these. And that equals x to the 7th times x to the 7th times x to the 7th, because you got an x to the 7th here, here, and here, and you can change the order of these things because they're all multiplied. And then that's times y squared times y squared times y squared. So that we can see that x to the 7th to the 3rd means we're going to have 3x to the 7th here. Okay. And that's going to give us x to the 7th times x to the 7th times x to the 7th, which is x to the 21st. Okay, so I can write that this way. That's x to the 7th cubed times y squared cubed. All right, when we write it out, we see we have an x to the 7th cube and a y squared cube. Okay, I can complete that. That's x to the 7th cube times y squared cube. That's what's x to the 7th cube? Well, because of this rule and because you can visualize 7 of them, 7 of them, 7 of them, when you cube it, you get x to the 21st. And here you get y to the 6th. What's that equal? Well, x to the 5th times x to the 21st. Again, visualize it. 5 of these and 21 of these, you're going to have 26 of them. All right. That's the reason. And you want to think in terms of reasons, not in terms of where the parentheses are and stuff. That's fine. Do it visually, but check it out against the rules. Make sure you are using the right rule by making sure you understand that rule. And these rules are not difficult to understand, but they're confusing. Okay, okay, well, that's looking pretty good. Last thing is solve a system by elimination. So here's a system of equations. Now, you can graph these, you can solve by substitution, you can do all kinds of things. The most common way we solve linear equations is by elimination. So I'm going to call this equation 1. So I'm just going to write a purple 1 over here. I get this thing out of my brace. So purple 1 and a purple 2, indicating purple 1 means equation 1, purple 2 means equation 2. Okay. Now, 2 times 1 means the number 2 times equation 1. Doesn't mean equation 2 times equation 1, because there's no circle around that 2. So, and actually, I'm going to do negative 2 times 1. That's the same as negative 2 times 5x plus 7y equals negative 2 times 4. And 10x minus 3y equals 9. Now, why did I do that? Notice that when I multiply through by negative 2, same thing as negative 10x minus 14y equals negative 8. Now we're looking at the system. We have this system the same as this system is the same as that system. This is the same as. In other words, has the same solutions as. Now, let me write this. Same solutions as if I don't want to write that. Okay. So pretend I didn't write that. Okay. I do. Equation 1 plus equation 2. Okay. Well, what do I get if I add equation 1 to equation 2? So I'm going to let you respond here. Okay. Okay, so we've got good answers here. It's pretty obvious. Negative 10x and 10x gives us 0. This is negative 17y equals 1. Okay. So we don't have to write that down. Y equals negative 1/17. Now, when you did substitution, of course, not everybody did the assignment, but when you do substitution, you plug in one equation into the other, and you get a solution for the other variable. If you remember what we did previously, I'm going to pull the board up now, but we've got like 48 seconds left in class. But if you do that, you're going to get something like a solution for y. So this is kind of equivalent to what happens with substitution. But now we can take this, sneak it up through here, and plug it in for y in one of the equations and solve it for x. So this gives us this equation. Right there is our value of y. Place y with the value we know it has to have if these two equations both satisfied. And that's the y coordinate, the point where the graphs would cross. Okay, then we quickly solve this. Went ahead and multiplied -3 by -1/17, you get 3/17. So I tell you not to skip steps, so don't skip steps, write it out. We have 170x plus 3. And 17 times 9 is 153. 170x equals 150. X equals 15/17. Now, I can check, but I don't have time to do that. But I check by plugging this and this into this equation. And let's see, 10 times, that's 150/17. And -51/17. No, plus 51/17. That's 201/17. That's not 9. So maybe I did something wrong here. Okay, if I plug these numbers back in, maybe I find that I made a mistake here. It kind of looks that way to me, but I'm not going to take class time and keep you over. And so I can ponder my mistake. You see the process. Okay. So you might want to just, after you do the assignment, you might want to write that down, work it out, and see if you get the same solution I did, or if you got the right one. Okay. But it's a pretty simple process. I don't think you're going to have a lot of trouble with it because your arithmetic looks pretty good. Okay, now we just had a question. I'll answer real quickly. Why did I use -2 here? Because I wanted these two numbers to be equal and opposite. So I figure out what number I would multiply by one of the equations so I can make them equal and opposite. Maybe in some cases I have to multiply by each equation by a different number. Like I could multiply this equation by 3 to get a 21y, and then this one by 7 to get a -21y. I could have gotten rid of y that way, but I'd have to multiply 2 equations. So I'm just giving you a brief introduction to this. Open Math will give you a good explanation. And of course, you have trouble with it, holler at me.